Sir, as you are currently working in multiple research areas, out of which can you highlight just one that you are particularly passionate about?
To briefly tell you, my research group revolves around the work of improving the combustion efficiency in internal combustion engines. So it's a vast area in which the country is utilizing various engines. At the same time, there is an energy transition going on where we are looking at fossil fuel to the renewable fuel or the cleaner technology. That's the area where I work very closely.
As you rightly mentioned about optical diagnostics techniques, so we would like to know more about this technique.
I will be very happy to show you the actual demonstration of the technique and explain you in more details. We all knew that COVID-19 was a very challenging time, and that was when we were really pressed what best you can do for the society. Based on that problem statement, we developed one small active vaccine filling box.
Are there any commercialization opportunities for this technology so that the industries would get benefited from?
In case of the manufacturing industry, when you are develop various new additive manufacturing techniques or the welding techniques, you need to have better and better optical diagnostic techniques for that.
How does your work aligns with the Atmanirbhar Bharat initiative of Government of India?
After we developed the product and then we started using, we realized that has a bigger application at different places. You are carrying the biological material from one place to another places. We did not have that technology. Again, going back to the Atmanirbhar Bharat, we have capability. It was just a matter of implementation of those things. So that was a very good and very satisfying work that we could do during that time.
As I mentioned in your introduction to our viewers, that you have something valuable to offer to each and everyone. So this is yet another addition to the same.
Thank you very much for inviting me to this InnoQuest podcast of IIT Indore. It's really an honor to be here and discuss about the technological development that's happening in my research group.
Hello everyone, welcome to the second episode of IIT Indore's InnoQuest Talks 1.0, where intellect meets innovation and thinking fuels invention. Today, we are lined up with a very interesting discussion with our esteemed faculty member, whose contribution in the technology development is significant for the industry and the society. I take this pleasure of introducing Professor Devendra Deshmukh before we engage in a technical discussion on one of his research domains. Professor Deshmukh joined IIT Indore in the year 2012 in the Department of Mechanical Engineering. At IIT Indore, Professor Deshmukh has been instrumental in advancing research in internal combustion engines, biofuels, spray, combustion diagnostics, and optical imaging. His work is particularly notable for its focus on improving fuel efficiency, enhancing engine performance, and developing sustainable energy solutions. Professor Deshmukh's dedication extends beyond research. He served as the head of the Mechanical Engineering Department from the year 2015 to 2018 and Dean of Academic Affairs from 2020 to 2023. He is currently the Dean of Educational Outreach at IIT Indore. In this role, he promotes collaboration with industries and academic institutions, both nationally and internationally, to promote the technological advancements and educational excellence. His research has direct applications in the defense and aerospace, including a project on high-speed optical imaging for explosion studies, which led to a joint patent with DRDO, ARDE Pune, and IIT Indore. According to my research, he has something valuable to offer to everyone, whether through the technical guidance or by providing the smaller projects to the BTech students. Today, we are fortunate to hear from him as he shares his insights and experiences. I'm very excited to welcome Professor Devendra Deshmukh to InnoQuest Talks at IIT Indore. A warm welcome to you, sir. Thank you for joining us today. Now, I would like to start directly the technical discussions with you. So, sir, as you are currently working in multiple research areas, out of which can you highlight just one that you are particularly passionate about?
Yeah, thank you very much for inviting me to this InnoQuest podcast of IIT Indore. It's really an honor to be here and discuss about the technological development that's happening in my research group. To briefly tell you, my research group revolves around the work of improving the combustion efficiency in internal combustion engines. So it's a vast area in which the country is utilizing various engines, and at the same time there is an energy transition going on where we are looking at fossil fuel to the renewable fuel or the cleaner technology. That's the area where I work very closely. I have been fascinated right from my research career when it started using the technologies which has the laser-based measurements. The reason being, these are the techniques which can be used remotely, and they give you measurements or the data or the analysis that that comes without any kind of the disturbance of the phenomena. So we have been working on this technology for more than a decade, and what we observe that many a times these technologies get hampered or has a limitations by virtue of availability of the lasers, high-speed lasers, or the hardware, imaging hardware, specifically the camera, CCD, ICCD, CMOS cameras, which are either not available by technologically or not available in our Indian scenario. So that kind of the limitations, we realized that like we need to work on it, and that's how I started working on the optical diagnostics using laser-based measurements in this particular area. Some of the work that I will like to share with you is for last 1 decade, I have been working on imaging the various colors in a single frame, what we call as a multispectral imaging. And the second work which we have recently worked on was imaging the high-speed objects using the compressed ultrasensing algorithms, wherein we were able to get the phenomena which happens in a sub-microsecond or some nanosecond time scales, we were able to image. So these were few of the areas, optical diagnostic techniques, that I have been working on in last 1 decade along with my research group, PhD students and master students. So that will be something interesting to everybody.
That's great, sir. As you rightly mentioned about optical diagnostics techniques, so we would like to know more about these techniques.
Yes, I will be happy to at least explain you one of the technique for the people to understand what exactly we are talking about. Now, one thing which I was explaining you, this like the combustion phenomena that I work on in the internal combustion engine. These phenomena happen at a very small, tiny time scales, usually milliseconds, microseconds, or even nanoseconds.
Okay.
To capture them, it becomes very difficult with the conventional cameras, wherein they are limited by the availability of the pixels, the availability of the quantum efficiency of the sensors. More importantly, the electronics, which does not allow you to capture multiple number of frames in seconds or so. That is when the technique that I have developed is the compressed optical sharing ultra fast photography, in acronym what we call as a COSU. This technique takes advantage of it is built on the streaking camera. So what it does, it takes advantage of capturing the image in a single part. At the same time, you try to share it and embed it with some certain kind of the algorithm, so that you will be able to get it back again into your algorithm part. So there are few methods in which this has been applied, where the strict camera was used initially. Later on, digital micrometer device was used, DMD was used, and then lot of evolution happened. What we were interested in is like, can we utilize this technique for the scenario when our resources are limited, or the hardwares are limited, or the electronics part is limited, and still utilize it. That is where we started working on this COSU part and develop the technique. I will be very happy to show you the actual demonstration of the technique and explain you in more details. So that will be in the lab. So we can go into my lab and look at it.
Oh,
Yes,
well,
right?
sir, we would be happy to go to your lab.
So let me explain you the technology in the laboratory setup. This is a small setup that we have developed to explain the complete technique for the better understanding. Typically, whenever your normal camera work, they have the exposure time or the time during which it takes the image in few milliseconds. Now, if the phenomena is happening at a higher speed, usually it goes as a streaking, or you see a blurred image on your camera. To give you example, when you try to take an image of a train when it is standing, you will see a complete crisp and clear image on your camera. However, if this train is moving at a higher speed, you will see that like it starts giving you the lines and the image is not clear. In reality, the image is captured. Only thing is that image capturing has overlapped on the same pixels or the same place again and again over a period of your exposure time. Now, what if somehow you are able to redevelop that particular image over a period of time of the exposure? That is what will help you to understand where the train has moved or where the particular object has moved. And that's the basic technique of a COSU technology that we are working here. Just to give you the complete setup idea about this particular technology, I have a small setup which has been developed here, and the dynamic scene or the train or the any object movement, I have replaced it using a letter M, which is inverted here at the particular place. So that's the object M that is inverted here that you can see. Now, we want to understand how this dynamic event has happened, that is captured even only in the single single frame. What we have to do is we have to embed some known factors in the particular image. So first one is this particular mask that is put up here that you can see. This mask is basically a pseudo-random mask, which is something like your QR code, which has been embedded. So the image M has been now captured or embedded with this particular code or the pseudo-random code, which can be seen here. Now, one part has been added. Now your object is moving with respect to that of your mask. Now what we have to do is you have to share this entire image with a known value or the known sharing part that we achieve using this particular mirror, which is rotating here at this particular. This is basically a galvano scanner which will share your image continuously, and you will be able to see this particular image on this part. So you can see an image which is flipping between two ends. That's the sharing of the image. Now, such a shared image, what you have embedded with that of the mask and the known velocity is the shared image, can be seen on this screen here, which now we will be passing it through our compressing algorithm, so that we will be able to peel off the complete time event which has happened over that entire image exposure, and we get the complete phenomena over the period of time. Now, this technique here, even depending on your exposure time, let's say it is in the millisecond, you will be able to get sub millisecond or sub microsecond time resolution for the event that has happened. If your camera is a CCD or ICCD camera which has microsecond exposure, you will be able to go sub nanosecond time resolution to understand this phenomena. Where does it help us in the combustion phenomena? Usually in the combustion dynamics, we see all those phenomena happening at sub-microsecond level. Our high-speed cameras are not able to capture these events. That is where we use this technique to understand this part. Plasma creations or the droplet dynamics, droplet breakup, droplet bursting. These are the phenomena which are used in our combustion diagnostics. But the limitation, it is not limited only in the combustion diagnostics. Other part in the aerospace, where the shock creation happens, there also it is used, or in the defense, where you have the warhead bursting, the tracking the high-speed particles. That is where this can be utilized, or even in the biotechnology, where you are trying to understand the tissues response. There also you will be able to utilize this technique that we have developed in our laboratory. So there is a vast area in which this technique will be utilized.
So thank you so much for this detailed information and the technology demonstration that you have given in your laboratory. Now, as you rightly mentioned about combustion diagnostics, so we would like to know more about what exactly this combustion diagnostics is and how these techniques are being used in the combustion diagnostics. We would like to know this from you.
Yeah, that's very interesting area. The combustion as such is there in our life at all the places. The specific area in which I work is in the engines, and you can see there like we are all use gasoline engine, diesel engines, or the gas turbines for that. Now with the changes which are happening or the energy transition that we talk about, we are trying to move towards the cleaner engine because the existing fossil fuel that we consume has a lot of bad impacts on our environment.
Yeah.
To mitigate that, we have to improvise this combustion. So what we say by improvisation means like the diesel engines which used to emit a lot of soot or the carbon dioxide emissions which are high, we have to work on how do we reduce these harmful emissions back from the combustion side. So typically what we do is we try to go to the basics of these phenomena, the physical phenomena which are happening. How does soot forms? So soot formation happens right at the middle of your flame, and those phenomena are highly transient. It goes on less than a millisecond or a microsecond time scale. It happens, and unless until we do understand this physical phenomena, we cannot move further to improvise the systems. That is where these optical techniques, the laser-based optical techniques, come into picture. What happens is like you are able to understand those transient at the same time you are also not disturbing that phenomena which is occurring in that environment. That is where the techniques that we have developed helps you. So even if you take the example of a flame, soot formation, or the spray which happens of the diesel or the gasoline, all those phenomena, we need these techniques to understand and improvise them at the basic level and improve our works.
Okay. Yeah. Thank you so much, sir, for this information as well. As we know that the entire world is shifting from the fossil fuel to the cleaner energy.
Yes.
So what is your perspective on this energy transition?
See, this energy transition is imperative, and it is going to be there for two reasons. One is these fossil fuels that we are consuming, they are all limited resources, and we do not have the infinite resources that we will go on. Our energy demand will keep on increasing. Second part to this is the emissions this fossil fuel burning provide, the carbon dioxide emissions, which is one of the greenhouse gas, which is very significant part. The second part comes into the NOx emissions or the hydrocarbon emissions. So government will and the entire world will move towards a cleaner part. If this is going to happen, then what are the alternatives available to us? The alternative available to us are the renewable fuels. Yes. Or we say that like we capture this energy in the different form. Nowadays we are talking about biodiesels, we are talking about biofuel, hydrogen, ammonia. When we are shifting towards these new fuels, we need to understand how efficient they are. It should not happen that like we end up in the bad scenario or their efficiency goes down. That is when we have to use these techniques to improvise from the existing scenario.
Yeah, that is why we will be using these techniques to understand the combustion.
To understand the combustion, like currently when we are extensively working on hydrogen combustion. So you need to have the techniques which will be able to capture those scenarios, and without that we will not be able to go ahead.
Yes, we understand that now. Next, we would like to discuss about the defense part as well. From a study that we got to know that you are working on multiple projects related to the defense.
Yes.
So how exactly you are using this diagnostic techniques in the defense project that you are currently working on?
Oh yes, that I will love to talk about that. In fact, the research work which I was doing during my early days, we were trying to look at the sprays, diesel sprays, and that is when we came across this defense project, wherein the idea was to look at these very high speed particles which moves at 1 kilometers per second or 2 kilometers per second, and they are moving through the combustion cloud, whether you can image it. Like that was a very challenging problem which was posed to us, and we took that challenge, and like during this entire process we were continuously improving our techniques. So in this particular project, we were using the direct inline holography technique to image the particles not only in the 2-dimensional but the 3-dimensional part, so that we will be able to capture. But these are very high speed objects, as I was telling during the example of a train. The moment their speed increases, you start getting blurred images, and then the error starts developing. That is when we started getting into more and more high speed phenomena capturing part. So for the defense and the aerospace industry, you all get these high speed objects or high speed phenomena going in the shock creation or the particle movement, and we are developing in that part. So that's really a challenging and fascinating part. Yes.
Sir, as you rightly mentioned in your technology demonstration as well, like there are applications to this technology in aerospace,
Yes.
or industrial processes, or even in the manufacturing.
Yes.
So to come to that point, we would like to know how the other industries would get benefited from this technology, or are there any commercialization opportunities for this technology so that the industries would get benefited from?
Yes, in fact, that is one idea. When we do the lab scale research, it is basically we are looking at not only the improvisation of whatever the phenomena we are doing, but how does the industry get benefited. Now, the aerospace industry or the defense industry, I was giving you example that like there are multiple high speed moving objects or the shock creations. There anyway, you do not have the existing part to understand how the shock interaction with the solid objects happens there. But not only limited to this aerospace, but even in case of the manufacturing industry, when you are developing various new additive manufacturing techniques or the welding techniques, you need to have better and better optical diagnostic techniques for that. One of the other area where these techniques can be used is in the biotechnology, when you are trying to understand the cells, in fact microchannels. At that part, this technique will be very, very useful.
Okay, I believe that our viewers will be so much interested to listen to all of this. Talking about one of the very important point, which is the self-reliance of our country.
Yes.
So we would like to know, how does your work aligns with the Atmanirbhar Bharat initiative of Government of India?
Yes, I will like to talk more about it. As I was mentioning you, initially when we started work, that was more on the combustion research. We have seen that the combustion research or any kind of the research in India, we are quite dependent on the hardware and software coming from the foreign countries, and many times we do not have access to such part. So the techniques that we started developing was in that direction only, that like we should be able to do our research with the resources that are available to us. So the high speed technique that I explained you, COSUP, is one part of it. Like when you have a camera which, if we have available in millisecond or microsecond exposure part, we should be able to take it to the further down the line with a higher speed images, or for that matter the multispectral imaging was also in that direction. When you do not have the availability of the cameras or the lasers, we will be able to take that. So we are working in that direction. In fact, as a part of this, we have also started a company which does the combustion diagnostics and fluid flow phenomena at the higher level part.
Thank you so much, sir. It's good to hear that your research is contributing to the self-reliance of our country. Now, apart from the technological questions, I have some few more questions that you are currently working with.
Yes.
So, as Dean of Educational Outreach, how are you engaged with the initiatives related to the school education or industries, or for say for the startups as well?
Yes, right. Yeah, definitely. I will love to talk about these another aspect of the administration that I am working. So we have this new section, that is the Dean Education Outreach Program, which has started at IIT Indore. The sole purpose of this initiative was to take the education to the other stakeholders of the society outside IIT Indore, how we can take it. So these stakeholders include the industry, these stakeholders include the society, these stakeholders include even the school education part of it. So for the industry, what we have done is, like, typically in the industry scenario, when the employees are working, they do not get time to improvise their education, they do not get opportunities for that. So that is where we have started the executive programs wherein they can take these executive programs in the online mode or on the weekend mode. They can come and study at IIT Indore. So one such programs we have started for the Volvo Asher, which wanted their employees to be upgraded so that the new technology, which is the electric vehicle technology, is coming up. How we can help them out. So we have started a very specially curated program on the electric vehicle for these people. So now they are coming on weekends, they are coming taking the courses on even on the online mode, and we have got a very good success in that. So similar programs we have for other industries, including the continuing education program. The second aspect is like how IIT being in the Madhya Pradesh can help to the society in the around part, or that help in improving the technical education. So institute has taken many initiatives. One of the initiatives is we get the undergraduate students from the government engineering college who stay at IIT Indore during the 8th semester, and they study along with the IIT students. They do projects, they get access to the research laboratories so that they can improvise on their learning there. They get the completely new experience when they are at such a premier institute. So that is for the technical education part. And then the third part, which we have been working for some time, is on the school education. So we have seen that the kids, they get exposed to various technologies in a day-to-day life. They have a lot of curiosity how we can help it out. So we have started a makerspace. In the makerspace, we have specifically curated a program for them, so these kids can come to the lab and develop on their own hand the small models. Sometimes we teach them how to use a 3D printer, how to mold it, how to start one small toy, create it on their hand. Sometimes we do explain them how you can do a small programming part. So that is for the school children's that we are doing these initiatives and continuing that part. So in fact, like we want to expand that particular area. The third one was for enabling and empowering those teachers, school teachers, for the experiential learning part. So if we are teaching it at IIT Indore, can this be taken up at the school level when they are teaching them the concepts in the mathematics or concepts in the science? If these small things can be helped, or they can develop something like a tinkering lab at their level. So we are empowering those teachers also. In fact, like we have successfully conducted one 5-day training program for the school teachers, and we got a very positive response for that. So as a function from the education outreach, I feel that that is the way how a premier institute has to give it back to the society or reach out to the society, and then that's what we are trying to do.
Yeah, that's amazing, sir. As I mentioned in your introduction to our viewers, that you have something valuable to offer to each and everyone. So this is yet another addition to the same. Now, as we know that during the challenging time of COVID pandemic, you had developed a vaccine carrier box just to help the society. So we would like to know more about this initiative.
In fact, like we all know that COVID-19 was a very challenging time, and that was when we were really pressed what best you can do for the society. One of the biggest challenge we were seeing that the last mile connectivity, when the vaccination started going out in the to the society, there was that at last mile connectivity for the cold chain was not there. Whatever we were using the passive cooling the chain boxes, and usually in the hot environment in our country, usually that temperature variation was happening, and that was one challenge which was faced. And exactly at the same time, the medical center also approached us like whether we can work. So we had formed a team with the expert doctors from outside and those who were working on that, and that is based on that problem statement, we developed one small active vaccine cooling box. I will tell you that was really a good input that we have done for the society. But not only that, like after we developed the product and then like we started using, we realized that that has a bigger application at different places. You are carrying vaccines at the remote places, or you are carrying the biological material from one place to another places. We did not have that technology. Again, going back to the Atmanirbhar Bharat, we have capability. It was just a matter of implementation of those things. So that was a very good and like very satisfying work that we could do during that time.
Oh, wonderful job, sir. As your innovation reflects your technical excellence, at the same time, it also reflects your deep sense of societal responsibility as well,
Yeah.
that you are supporting the society also. So, one thing that we have observed that your aura always appeared to be so balanced with, reflecting a calm yet a joyful personality. So, in your professional as well as personal life, how do you balance these two things?
Yeah, in fact, whenever we are working for the society, probably I feel that like we get the positive energy from the society itself or the surrounding environment, and again the kind of the environment that is provided by the institute at IIT Indore, it's a really positive part. So whenever we talk with the students, whenever we talk with the colleagues, we always feel that like we should be doing something new and helpful for the society. In fact, that gives a lot of energy. Apart from that, I try to take some morning walks or play some games. That helps
Oh,
me a lot to maintain that portion. Otherwise, that's the energy which comes from the surrounding people.
oh,
Thank
that's
you.
good. Thank you so much, sir, for taking out time for us and dedicating your time for this discussion
Yeah.
and sharing your insights on your technology and about the educational outreach as well as your work for the society. Thank you so much,
Yeah.
sir, for all of these things.
Yeah, thank you very
And
much, and thank you very much for
thank
me
you,
having me
thank you.
at the inquest.
I believe that our viewers will be having so much to take away from this discussion with yours.
Yes,
Thank
thank
you
you,
so much, sir.
thank you, thank you.
To our viewers, we hope you gain valuable knowledge from Professor Deshmukh's expertise. If you are interested in technology transfer, feel free to reach out to us via the email displayed on the screen for collaboration opportunities. InnoQuest Talks 1.0 will continue to bring more engaging discussions on research, innovation, and technology at IIT Indore through our YouTube channel InnoQuest Talks at IIT Indore. Until next time, keep innovating and keep exploring.